am going to explain about monolithic kernel and microkernel. First, before going to learn about monolithic kernel and microkernel, first we learn about what is kernel. A kernel is a program that allows communication between software and hardware. When we start our computer, the first thing that gets loaded is the kernel. It is responsible for providing secure access to machine hardware for various programs, and it is responsible for deciding when and how long a program can use a certain hardware. And the kernel is the heart of the operating system. The different approaches are adopted for building an operating system kernel based on the kernel design, and kernel can be designed classified into 5 types. In our syllabus only we have 2. First one is monolithic kernel and second one is microkernel. First one is monolithic kernel. In monolithic kernel architecture, all kernel services run in the kernel space. Here, all the kernel modules run within the same memory space under the single kernel thread. The tight internal integration of kernel modules in monolithic kernel architecture allows the effective utilization of low-level features of the underlying system. And monolithic kernel advantages: it gives the high performance, but it is high risk for system crash. How it is responsible for high risk system crashes? The major drawback of the monolithic kernel is that any error or failure in any one of the kernel module leads to the crashing of entire kernel application. Examples for the monolithic kernels are Linux, Solaris, MS-DOS. Next one is, here we will learn about the architectural representation of the monolithic kernel. In monolithic kernel, applications are there. Here in diagram you can see applications are there. In applications and in monolithic kernel, all the program or code will be run only in kernel space. Applications are there, and here monolithic kernel with all operating system services running in the kernel space. Next one is microkernel. The microkernel design incorporates only the essential set of operating system services into the kernel. Here in microkernel, the essential set of operating system services are only run in kernel space. Rest of the operating system services are implemented using a program known as servers, which run in a user space, which provide the highly modular design and operating system neutral abstract to the kernel. Microkernel. Next, memory management and process management and timer systems and interrupt handlers are the essential services which form the part of the microkernel. The bare minimum of the, already I told, the only essential part of the or bare minimum code is run in a kernel space, and rest of the operating system run over the user space. It gives advantages excellent separation, but microkernel gives a poor performance. The architecture view of the microkernel, it is, here services are there, kernel service running in a user space, and here application is there. Only essential set of the kernel will be run over here kernel space, and rest of the microkernel with essential services like memory management and process management and timer etc. run over here. Next will be the microkernel based design approach offers the following benefits. First benefit is robustness. And second one is configurability. First one is robustness. If a problem is encountered in any one of the services which run as a server applications, the same can be reconfigured and restarted without the need for restarting the entire operating system. And thus, this approach is highly useful for systems which demand the high availability. Robustness in microkernel, this approach is highly useful for systems which demand high availability. Second point is, since the services that run as a servers run on a different memory space, the chance of corruption of a kernel services is ideally zero. In monolithic kernel, all the kernel modules are run over kernel space, but here microkernel, the only essential part will run over a kernel space, so that here is chance of corruption will be very less. Second advantage is configurability. Any services which run as a server application can be changed without the need to restart the whole system. This makes the system dynamically configurable.